Hello everybody. In this video tutorial I want to explain the new feature that I added to scenProc to detect features from imagery. In this video tutorial I will first give a short presentation about the sort of background of how it works, so that you understand what the different parameters do, and after that I will demonstrate how the feature works within the scenProc tool. So let's get started. This new feature sort of was added because I was trying to create autogen for an area where I couldn't find good vector data of the vegetation. It's the Nantucket Island in the United States, and I used it as a test area to test some new scenProc features. And I made a photo scenery of that area, and I wanted to populate it with autogen. But I couldn't find good vector data with accurate vegetation and forest for the island. So what to do in that case? That's the sort of challenge that led to this new feature of scenProc. And of course well, maybe I shouldn't say obvious solution, because it's not an easy solution, but the solution is to try to detect the vegetation from the imagery that is used for the photo scenery. So look at the imagery, look at the photos, and try to recognize where there's vegetation and where there are other things. And that's what the new detect feature step of scenProc can do for you. It can detect certain features from the imagery. I've mainly tested it with vegetation until now. But I think if you tune the settings a bit, you can also detect other features and then create vector data for them that you can use later on in scenProc to create autogen or other objects. So how does it work? There's basically a two-step workflow. The first step is that you use the detect features step to create new vector data of the features you want to detect, so for example the vegetation. And the second step is that you create autogen from that vector data. So the second step is basically what you would normally do as well if you could find good vector data. I split it here in two steps because the first step, to detect the features, can take quite long. For example, for the island that I'm testing it on, it took about 80 minutes to process all the photos and create the vector data. So you don't want to do that all the time. Like every time you want to regenerate your autogen, you don't want to go through that lengthy process as well. So basically you run it once, you save the result as vector data, and then you can use it as usual in your workflow to create autogen. What kind of input data does it take? I already mentioned that it uses the imagery to create, to detect the features. But it's important to know that scenProc cannot read your photo scenery BGL file. The format of that BGL file is not publicly known, so it's not possible to read it at the moment. So if you want to use this detection feature, you need to have the sources of your photo scenery. So for example, the sources you download from the USGS website or from other sources, from other websites. And it's also important that the photos that you're using are geo-referenced, so that they contain information about where on Earth they are located. That's important because the vector data that's being created from the photo should have the right geolocation as well. So usually it's best to use GeoTIFF files. These can be read by resample as well when creating the photo scenery, so maybe you already have them. But any other format supported by the GDAL library should also work, and that library supports quite a lot of formats, although I mainly tested with GeoTIFF until now. And another thing is that if you want to have better results for the vegetation detection, it's also important, or it's better to have a imagery with a fourth channel in there, also a near infrared channel. So not only the red, green, and blue channels that are usually used to give the colors of the photos of the photo, but also a near infrared channel that shows the reflection in that part of the spectrum. And that's important because vegetation has sort of characteristic reflectance in that part of the spectrum, and that makes it much easier to create the vector data. So with that as input data, then the basic detection process is the 3 steps that I put here, how I implemented it in scenProc. It's first I'm looking for potential pixels that could be the feature we're trying to detect, vegetation here, and I have two ways to do that identification, either NDVI or histogram based. I will explain in more detail what that means later on. But it gives sort of potential pixels that could be vegetation. Then the second step is to filter out noise or other small sort of pixels, small objects. That's done based on a user specified parameter that says what the minimum size of a tree should be. So you can imagine that like a decent tree is easily 2 or 3 meters in size, and then based on the resolution of your imagery you know that okay, a tree should be at least so many pixels in size, and if it's smaller than that, then it's probably not a tree that's being detected, but some other faulty detection maybe, or some noise, so we want to filter those out. And then the last step is that I add a buffer around the detected vegetation to make the vector polygon a little bit bigger again. I do that because if the sort of polygons are too small, no vegetation will show in Flight Simulator. The FSX engine will ignore sort of small polygons. So that's why I enlarge them a bit again, so that the AutoGen shows up in Flight Simulator. So let's have a quick look how that process works. Here's a sample from some imagery of the Nantucket Island that I used for the test. This is the 4-band imagery. It has the near infrared channel as well. And this is just how the imagery looks, and then I applied the NDVI based filter on it, and I'll explain more how that works later on. But that gives me the areas here shown in red as potential vegetation. So if I flip back to the imagery and show you this one again, you'll see that, for example, here at the top there's a lot of pixels being detected that, well, they're not really trees, at least. They're, I think, some bare ground with maybe some grass or so. So we don't want those there. So that's where the second step comes in. We filter out all the small parts, and then you see we have much less left. You see some red dots here and there. You also see that some of the vegetation is missed out. So maybe I could have tuned my parameters a little bit better. But you see, it's not a perfect algorithm. And then the last step is that we enlarge the found areas again and cover them sort of by a bigger polygon, and this is then used to create the AutoGen for Flight Simulator. And if you look at this result, you see that the vegetation here in the middle is covered quite well. Here's probably some false detection because there's no tree there. Here the trees in the middle are also a bit covered. There might be a tree next to this house, so here's a tree which being covered. So it gives quite good results, although you will always find some parts where it's not completely perfect. So let me quickly come back to the two detection methods that are implemented. One is based on the NDVI, which is the normalized, forgot what the D was, differential, I think, vegetation index, which is a sort of index to indicate if there's vegetation somewhere, and it's based on the near infrared channel. So it's calculated by using the red channel and the near infrared channel of the imagery. And basically, the higher the NDVI value is, the more likely it is that you find vegetation. And negative values should normally indicate water. So that's another interesting potential. But I also found out with the imagery that I tested with that things are not as black as white as the theory explains it. For example, I also found that many roads or the runway of an airport also had a negative index. So they would be classified as water as well if you try to classify water. And the same for the sort of higher values where there are vegetation. Sometimes some shadows of a building or other things also get similar values to the vegetation. So that's why you sometimes get some false positives, as you saw in the previous pictures. And then the second way to sort of classify pixels as vegetation is by looking at the histogram values of sort of the neighborhood of that pixel. And with that I mean that sort of for each pixel that you look at, I sample some neighboring pictures around it, and the size of the area being sampled is again an attribute that you can change. And then within that area, we can look at what's the average color, what's the standard deviation of the color, so how much variation is there in color. And based on these characteristics, it's also possible to identify vegetation. So for the second approach, you need to tell scenProc sort of what are acceptable values, what is good vegetation, and then it will try to find other areas of your imagery with similar characteristics. Okay, enough talking about the theory now. You probably want to know how it works within scenProc. And hopefully I can also make the theory a little bit more clear in the tool. So here I jump to the scenProc tool. And let's first have a look at sort of how to run this detect feature step. It is quite simple. As you see, it's a really simple configuration file I have here. First I have a step that says import GDAL. It's a new one as well. It's used to import raster data imagery using GDAL. And I can just tell it sort of in this folder I want all TIFF files, all GeoTIFF files. Then I have the detect feature step where I say I want all features that are type raster. I want to apply this configuration file, and that configuration file tells scenProc sort of how it should filter, how it should detect the vegetation. And then the last two attributes are the what attribute should be added to the newly created vector data. So I want an attribute with the name obj, like object, and I will assign it the value forest. And then the last step I do is just to save everything to a shapefile, so I can use it later on in my other scenProc configuration file to create the AutoGen. So this is a simple configuration file that makes a shapefile for your vegetation. And as you can imagine, it's this configuration file where most of the magic is stored, because there you need to tell scenProc how it should process the imagery and detect the things you want to detect. And to make that configuration file, you have a texture filter editor here in the tools menu. And this is a new editor in which you can make that configuration file. Once we're done with making the configuration file, I can save it here. And then you save it to disk, and that's the file that you will then load in scenProc, which you saw before in the processing step. The idea of this tool is that you load a couple of small images, sort of that are representative for the area you want to process. And on those images you can then test the whole procedure, and then later you can apply the same settings to a bigger area. So I have a folder with test images here, for example for band, so this is with the near infrared. And let me I'll load two of them. Well, this is the one I used in the presentation, and I'll add another image. Let me see. We'll pick this one as well. So I've loaded two images now. I can easily switch between them. And then here I can see all the settings for my filter. And in this case it's the NDVI based filter. So I can set all the things I just explained to you, like the buffer size is the size of the buffer that will be added to the detected features. I can set a minimum and a maximum value for the NDVI index. So in this case, all pixels that have an index between 0.15 and 1 are included. Sample size for the histogram based calculations, and yeah, well, let's just run it like this, and I run detect, and now it will go over those two images. And if you pick images that are not too big, it will be relatively quick. You see there's a progress bar in the bottom, and now it's done. And you see that the image changed to a sort of, like I can see the image, I can see the detected trees, and I can see a merge of the two. When you see here that it sort of detected a lot, but maybe also a little bit too much in some areas. Some parts it detected things that are maybe like here there are some trees, but it also identified some of the other areas around it. If you hover your mouse over the image, you will see here in the bottom left corner, you see the NDVI value, you see the average and standard deviation for the different channels. So that allows you to also have a look at things. And for example, you see the trees that I'm hovering over now have an NDVI index of around 0.4. Well, indeed, here this sort of bare land has an index of 0. And this tennis court here has an index of minus, around 0 as well. So there you can sort of see how it would work. If I now want to have less areas being detected, I can add a minimum standard deviation. And what I found out for this imagery, but it might be different for your area, is that some parts that were detected as vegetation but were sort of more grassland or so, they had a quite low standard deviation in the blue channel. Means that there's not too much variation in the blue channel. And if I say that the minimum standard deviation should be 5, and then run detect again, I will get a less sort of pixels being detected, because those that don't meet that criteria will be filtered out. But the result is maybe not so shocking here. I think it's probably more clear on this picture. Let me run it again with the previous settings. Okay, what you see here is that with the sort of simple settings without using the standard deviation, this part is all detected as vegetation, because it has a NDVI index of around 0.25. But you can see it's not really vegetation. It is probably some low grass or whatever. But if we here look at the standard deviations, you can see that it has quite low standard deviation in sort of, for example, the blue channel. While if I go to a tree or a forest area, you will see that it has a slightly higher value. So that's because there's more color difference in the vegetation. Actually, maybe I can even better pick the alpha channel. So if, for example, I say that the standard deviation in the alpha channel should be at least 5, and then I run it again, then we'll hopefully get less vegetation there. And it's running again. Well, we see it didn't completely work yet, so I can increase the value a bit. And now we have it almost gone. Well, you can imagine that this way you can sort of tweak and tune the settings with a small set of representative images. Well, you see now I sort of made the setting a bit too strict because I removed too much vegetation. But you can quite quickly try what setting works good for your area. Then you save that configuration with the save button, and then you can run it on your much bigger area. So this is for the NDVI based filter. Let's just have a quick look also at the histogram based filter, because it works slightly different. One thing you will notice is that I will use this image as a sample again. there are much less settings. You still have the buffer size and the sample size, and the minimum feature size. But the other two settings here are the allowed sort of tolerance, the allowed difference in the average value, and the standard deviation value. How this works is, you also see if I hover my mouse over the image, you see those 4 sliders. The idea is that with my left mouse button, I click on a couple of vegetation areas that I want to detect. So it's sort of to learn the tool, okay, this is the kind of pixels that I'm interested in because they are vegetation. Let me see, there's a tree. So I just click randomly on a few of them, and you see that those are then colored in green. If I now press detect, it will go over the entire image, and it will look for pixels that have a similar characteristics in the sort of the average color and the standard deviation of the color as the pixels I just clicked. And well, we see here's the result, and you see it detected some of the vegetation here. It also missed some of the vegetation, so maybe I do a few more mouse clicks in sort of the vegetation areas here that it missed. You also see that it detected some areas that are not vegetation. If I want to exclude them, I can do instead of a left mouse click, I can do a right mouse click. And you see there's some red there, which sort of indicates, okay, those red parts are pixels that should not be considered vegetation, while the green ones are settings that should be considered as vegetation. And well, then I run it again, and the idea is the same as with the NDVI based filter, that you can run multiple samples and in the end get a setting which quite well detects the vegetation. I mean, what I see here, except for the few hits there, looks quite good. And I can have a look at the other image, and then we see that in this case on the other image it didn't really work well, apparently because the trees have slightly different color values. So we would have to add some extra samples for this image, and once I found a set that works quite well, I can save the configuration again and use it for the sort of processing all of my imagery in scenProc. But like I said earlier, if you can use the NDVI based filter, from my experience it works better. But the only requirement is that you have imagery with 4 bands with the near infrared channel. Okay, so that was my quick demonstration of this new feature, and I hope I could get across a little bit how it works as well, that I didn't go too much into the technical details. What you see here, the AutoGen here, is the vegetation on the test island, and it has all been generated with this approach. And well, like I showed you in some of the images before, if you look closely, you will find places where there's a tree misplaced or where maybe a tree is missing. But in general, it feels quite natural with a cluster of trees here and there, and it aligns quite well with the imagery. Okay, so that's the end of this video tutorial. If you have any questions about this new feature, please visit the FS Developer forum and post your question there. If you want to know more about the scenProc tool, you can find the information on my website scenerydesign.org. There you can also download the latest version of the tool with this new feature included. Maybe one last remark. You will see that with this new feature I'm using the GDAL libraries, and those are quite big files. So I have split scenProc into 2 versions now. You will find one version for 32-bit operating system and one version for 64-bit operating system. So be sure to download the right version for the Windows version that you are using. Okay, thank you for watching, and once again, if there are questions, I'm happy to answer them on the forum.